Hey guys, so this is another video on data cleaning for machine learning. So in the previous video, we discussed how to treat missing values, logical variable, and character variables, right? Because machine learning algorithms often cannot handle these types of variables or issues, right? But there are other types of data that um, you do not have to address in the data cleaning step, but you still want to examine the correlation with the target variable, right? So strings or the text data is one of them. So what is strings? So let me use horror movies data set as an example. So here, this data set contains information about horror movies. So ID variable here represents um, basically, unique numbers that identifies each movie, right? And then we have title here. This is an example of strings because they're not categories. The students are often confused with strings and categorical variables. So categorical variables are like this, original language. So like EN probably means English and ES Spanish, right? Those are categories, and these are not categories. So one of the ways to tell separate strings from categorical variables or factors in the world of R is to check um, number of unique values. Strings are often unique, and therefore the number of unique values are close to number of rows. So let's do that here. Schemr, skim, and for movies. So the titles here. So this whole data set has more than 32,000 movies. Now look at the title. The title is near 30,000, right? But look at the language. There are 97 different types of language that's in this movie data set, right? So again, strings are often unique in each row. So the numbers are very close to the number of rows in the entire data set. Okay, so that's one way to get a sense of one way to separate strings from factors. All right. So title here um, is an example of string, and the target variable here is uh, vote average here. So vote average, people are surveyed and they cast a vote. Oh, I like this movie. I like that movie. Or they were asked on a scale of 1 to 10, or something like that, right? So if you're to look at vote average, what's the range? Vote average is from 0 to 10. So yeah, yeah. So 0 to 10, right? Okay. So that is uh, some info about the movie data set and the type of analysis you want to do to get a to examine the correlation between this string variable title with the target variable vote average, right? So here, what we have here is um, so these are words in the movie title, and word count is on the horizontal axis, and mean vote average on the y-axis. So, I mean, wording is a little confusing because the variable name is vote average. So that's the average across people, right? People's vote. Now, this is mean over the average because this is mean across words, right? So, let me take an example here to explain. So in this plot, this one word, the video stands out, right? So video shows up more than 100 movies, right? More than 100 movie titles as a word video. And this red dotted line is the overall average, vote average, okay? So on average, all movies in the data set has about 3.3 vote average, right? It's far below. Most other words are closer to the average, but the movie that has the word video in the title is close to 1. That's an outlier, right? So what this plot is telling us, I mean, if you're a movie producer or a movie producer, it probably means video is the word that you want to avoid in the title, right? So how do we create a plot like this? Right. So let's try this. So I already loaded horror movie, and you also need to install and load Tidytext package. That is for text analysis. So what you need to do is horror movies, and then you need to do so let's all right. So let me do it here. So horror movies, and there is a function from the Tidytext package, unlist tokens. So unlist tokens, you can see that the first argument is a data table, and then output and input. And the token, the default value is words. What the token means is you want to, what you're doing here, unless with the unless token function, is you want to break a string into smaller pieces and find the correlation with the smaller pieces with the target date. Okay, so most often, smaller pieces in a string is a word, right? So here, the data table is already provided, that's all movies, and it tag output will be word, and input will be title. So if you execute this, control enter, we got all these variables that we don't need for this analysis. So what you want is you only want to keep the ID variable, ID, and then the title and vote average, right? And then just run this again, control enter. So we have this, right? So check how this data set changed. So this, uh, so I want to show you how the data changed. And that is important. You should always check out what your code does. Okay, so this is what it looks like, right? This is original data. We only selected the three variables. So the very first movie is Orphan First Kill, right? ID 760161, and vote average is 6.9. And see how it changes with unless tokens function. You can see that the first three rows in the new data set all has the same ID. And look at the word. It's orphan, forest, kill. And that's all from the same movie. And vote average of 6.9. So this is unless tokens process, right? So what we want, again, is we want to filter for the most common words, and see any of the common words in the title has any predictive power for vote average, right? So let's keep going. So what we want to do here is, the other thing, um, is in tidy, the text analysis, the thing that we most often do is removing meaningless English words. It's hard to see here. Oh, yeah. So here, like the, right? That shows up. So let's examine this further. So when you examine these words, it is the, so very common English word that has no meaning. The shows up here again. Um, the my probably doesn't have any meaning. Uh, yeah, for it, all these words probably doesn't have any meaning. So what we usually do is there's anti-join stop words. So stop words. So if you just select Control Enter, stop words looks like this, right? So it has these words, it has collection of all these very common but meaningless English words. So with the anti-join process, we can remove them from our data set. So you see here, look, up to that point, we have 90,070 rows. But once you process it with anti-join, with the stop words, look, we only have 63,000 rows, right? We have a lot fewer rows because we removed, so look here, the is gone, right? Okay. And then remember, we need to create word count and also mean of vote average per word, per word. Okay. So what we can do here is group by word, and then we summarize. So what's the variable name? Word, um, um, number of words, and then function n. So that will count number of rows per word. Okay. And then we're going to calculate mean, vote, average, mean of this vote average. So vote average here, right? So mean of vote average, right? And it looks like this. So it looks like this. So like 0 shows up 6 times, and the title that has 0 showing up, right? There's 6 of them, and their mean vote average is 3.68, right? And we want to remove the words that doesn't show up frequently enough because they could just be average, noise, right? So here, for that purpose, we can use slice max. To slice max, the first argument is data, second argument is ordered by, um, another argument is n, how many. So we can slice or select rows by um, this uh, n words that we created. So the frequent words and how many? Maybe 50? Yeah, 50. Okay, so let's slice max, git tag, order by, what's the name? N words, and git tag, and then n, how many? So let's do 50. 50 most frequent words, right? And then control enter. So there we go. So now, so look at the number of rows. So we have, it's all sorted. So the most frequent word in the whole movie title is dead. The second most frequent word in the whole movie title is night. And 2 is the third highest. Don't know the reason why. Oh, maybe a sequel, right? Sequel. All right. Okay. Right. So let's save this under data, alt dash. And we need this overall average, the red dotted line, and that will be, um, so that will be mean, all movies, dollar sign, and vote average. So control enter. So that is the overall average. So let's say that your mean or overall vote average, alt dash, control enter, and we'll save this too. I'm not sure if I executed this, control enter. All right, so now we can plot this. So let's plot. So data, ggplot, and x-axis and words, and then y-axis mean, vote, average, right? And then we want to join text, the statics, and then label. Label is what word, right? So let's see how it looks. Control enter. Okay, it looks like this. So now we need to add the horizontal line, GeoH line, git tag, y-intercept, and provide overall group average, right? Control enter, and we can change that. We can change that line or um, customize it. So we can do color. So git tag um, color. So we can do red. We can do line width 2. Hit enter, and line type. Got it. And control enter. So yep, that looks very good. The only other thing is the labels, right? So labels, class, title, um, so words in movie title and popularity. And in the y-axis, what do we have? Mean, vote, average. Then x-axis, we got word count, right? Control Enter. So there you go. So this is how you can. This is an example how you can see whether a string variable in your data set might have predictive power. And so you want to take this to um, model building. So based on this, it looks like some words might have predictive powers such as video, right? Right. Um, so that's it for how to treat string variables. I'll see you in the next video.